Chapter 7, Lewis Structures, Homework Question number 3. What is the Lewis structure of phosphorus trichloride? So make sure you understand if just the name is given, you have to be able to write down the formula of the chemical. So first, we need to find out the total number of the valence electrons in this molecule. Phosphorus has 5 valence electrons, and then chlorine or chloride should have, so chlorine actually should have 7 valence electrons. Therefore, 1 fluorine, that's 5 electrons, and then 3 chlorine, each has 7. So then that's 3 times 7, that's 21 plus 5, 26 electrons, valence electrons in phosphorus trichloride molecule. Next, we are going to determine which one is a central atom. So since fluorine is less electronegative than chlorine, we say phosphorus is the central atom. Since we already determined phosphorus is a central atom, we'll draw the skeleton structure of this molecule. So 3 chlorine atoms, so just around phosphorus. So please note a single bond. So like here, those are 3 single bonds. That means 2 electrons, okay? And that 2 electrons, when we count the number of electrons for phosphorus, we just consider the 2 electrons belong to, let's say, phosphorus. As a matter of fact, of course, they share. But when we count the number of electrons, we'll say 2 plus 2 plus 2, 6 for phosphorus. For phosphorus, 6 electrons already there. Okay, so, and then for each chlorine, for each, just 1 chlorine, how many electrons? Only 2. For this one, 1 bond, 2 electrons. And for the other 2, the same way. Please recall we already learned the octet rule, which means each atom surrounded by 8 electrons, that will be the most stable state. In order to satisfy the octet rule, so each fluorine still need 6 more electrons. All right, so for each fluorine. Now let's assign those electrons. That's 6 already, is that right? 3 pairs, 3 lone pairs, that's 6, plus these bonding, the 2 bonding electrons, that's 8. Same thing for the other 2 chlorine atoms. Now let's take a look at phosphorus, the central atom. It already has 6 electrons surrounding it. It will need 2 more electrons to make it, to satisfy the octet rule. So 2 electrons, 1 pair. Okay. Now let's take a look whether this structure is completed. Okay, the total number of valence electrons in the molecule is 26 electrons. Okay, now let's count how many valence electrons have already been assigned. All right. for each of the 3 chlorine, there should be 8 electrons. All right, so 8 electrons. And then so there are 3 chlorines, 3 times 8, that's already 24 electrons. 26 minus 24, still 2 more electrons uncounted. Where are the 2? Right here. And now you see phosphorus has 6 bonding electrons and a lone pair, which means 2 non-bonding electrons. So therefore, all of the 26 valence electrons have been correctly assigned. So then this has to be the correct Lewis structure for phosphorus trichloride. This is chapter 7, resonance and formal charge homework. Question number 1. So below are 2 resonance structures for isocyanate ion. It carries -1 charge. Those 2 structures are drawn too close to each other. That's why I put a line there. That means, there are 2 separate structures, not 1 structure. Okay, so the first one is structure 1, the second one is structure 2. Okay, so question 1a, determine the formal charges on the atoms within each resonance structure. So both, of course, are resonance structures, but we need to calculate the formal charges of each atom. Now let's recall the equation for calculating the formal charge. That can be calculated using the total number of valence electrons of that atom, subtracted by the non-bonding electrons, means just the lone pairs, and then subtracted by 1/2 of the bonding electrons. Now let's work on structure 1. First, let's do nitrogen. So the number of valence electrons for nitrogen, that should be 5, because it's in group 5A. So 5 electrons. And then the number of non-bonding electrons, there are 3 lone pairs, a total of 6. And there's 1 single bond right there, that's 2 electrons. 1/2 of the 2 electrons. So that should give us -2 for nitrogen. Now we'll do the same for carbon. The number of valence electrons, that should be 4, because it's in group 4A. Number of non-bonding electrons, 0. There's no non-bonding electrons. There are no lone pair whatsoever. And then 1/2 of bonding electrons. Okay, bonding electrons on this side, that's 2. On this side, even though there's a triple bond, but you see each line represents 2 electrons. So therefore, that's 6 plus 2, that's a total of 8. And then that should give us 0 for carbon. Now formal charge for this oxygen, it's in group 6, 1 lone pair, 2 electrons, 1/2 of 6 bonding electrons. That gives us a +1.